Hello everyone, welcome to my channel. Now in this video I'm going to show you the derivation for the expression for radial acceleration. Now this is a circular path along which a particle is moving, and suppose at some instant the particle is at this particular position and this is marked as P. Okay, and this is the radius R, and I'm dropping a normal from this particle along x-axis. So suppose this distance is marked as xp, and along y-axis it is marked as yp. Okay, and at p, if the particle is moving in anti-clockwise direction, and if at p I draw a tangent, that tangent will give the direction of velocity at p. Okay, so now this is the velocity of the particle at this particular instant. Now this velocity, this part, suppose this angle is theta, this angle is theta. So at p, if I take this point out, this is point p, so this is the velocity v, and this is the vertical component along y-axis, and this is the component along x-axis. Okay, now see this velocity v, if this point p is at this particular location, angle theta will be 0 and this velocity v will be along y-axis. So that means I can say that this angle theta is equal to the angle made by v with respect to y-axis. Okay, see, if this p point is at this particular location, v will be directed upward along y-axis. So along y-axis, so at that time velocity vector will be making an angle 0 degree with y-axis, and this theta will also be 0 if p point is at this particular location. Okay, so we can say that this angle theta, these two angles will be equal. Okay, so the component along y-axis vy, it will be v cos theta, and component along x-axis, this component, it is vx is equal to v sin theta. Okay, so these are the two components of velocity. Okay, but see, this v sin theta is directed along negative x-axis, and vy, that is equal to v cos theta, is directed along positive y-axis. So velocity v can be written as this is directed along negative x-axis, so minus v sin theta I cap plus v cos theta into j cap. Okay, now in this triangle, this right angle triangle, if you see how much is sin theta, sin theta will be yp by r, yp by r. Okay, how much is cos theta? Same triangle, cos theta will be xp by r. Okay, so if we substitute these values over here, we get velocity v as minus v into yp by r I cap plus v into xp by r into j cap. Okay, now this is the expression for velocity. We need radial acceleration. Now acceleration is rate of change in velocity. So since acceleration is dv by dt, okay, so let us differentiate this expression with respect to time. So from this dv by dt, it will be equal to how much? Minus v by r is constant, dyp by dt to I cap. Okay, I hope this step is clear to you. Then plus v by r dxp by dt multiplied by j cap. Okay, so now this is dyp by dt, dxp by dt. Now what is dyp by dt. dyp by dt is the velocity of the particle along y-axis. So I can write dyp by dt as vy and dxp by dt as vx. Okay, now what is vx? vx is minus v sin theta and vy is v cos theta. Okay, so if you substitute those values over here, what do we get? dv by dt is equal to minus v by r. Okay, now dyp by dt is vy and vy is v cos theta. So this is v cos theta I cap plus v by r. Now this dxp by dt is vx and vx is minus v sin theta. So this is minus v sin theta into j cap. Okay, so this reduces to dv by dt is equal to minus v square by r cos theta I cap minus v square by r sin theta j cap. Okay, so what is this? dv by dt is the acceleration. Okay, so this acceleration I can write it as ax I cap plus ay j cap. Ax is the x component of acceleration, ay is the y component of acceleration. Now if we equate the coefficients, what do you get? We get ax as minus v square by r cos theta and ay as minus v square by r sin theta. Okay, so now we have ax and ay. So what is the magnitude of acceleration then? Magnitude of this acceleration, a magnitude, it will be how much? Square root of ax square plus ay square. So that is equal to how much? Square root of minus v square by r cos theta square plus minus v square by r sin theta square. Okay, now this is cos square theta and this is sin square theta, that is equal to 1. So the magnitude of acceleration, it comes out to be v square by r. Okay, what is r? R is the radius of the circular path, and what is v? V is the speed. Okay, and this is the expression for centripetal acceleration, or we can call it as radial acceleration. Radial acceleration. Okay, what does this negative sign? See, ax and ay both are negative. What does it shows? It shows that if this is the circular path in which the particle is moving, okay, this was point P, ax is negative, so this is ax, ay is also negative, so this is ay, and their resultant is along this direction, okay, along the radius. But how to prove that this resultant will be along the radius and not somewhere in some other direction? So for that you need to find, suppose if I take this angle to be phi, okay, so what will be the value of tan phi? Tan phi will be ay by ax. Okay, ay by ax. Now if you substitute the value of ay and ax, what do you get? You get minus v square by r sin theta divided by minus v square by minus v square by r cos theta. So this cancels out and we have tan theta. So tan phi is equal to tan theta. That means phi is equal to theta. But what is theta? Theta is this angle. theta is this angle. Okay, so since theta is equal to phi, that means A is directed towards the center along the radius. Okay, so this acceleration is directed towards the center along the radius. So this acceleration of the particle, it will be along the radius. Okay, it is for this reason this acceleration is called radial acceleration. So I hope this concept is clear to you, and this derivation part is also clear to you. I will attach this picture in PDF format in the description box. You can download it. So thanks for watching.